Saif. He's head of products at Panther Protocol. So we're going to be doing a dive into decentralization and core concepts of Web3 and blockchain today to kind of kick things off. So, Saif, take it away.
All right. Thank you so much. And thank you, everybody, for joining. Well, just a little caveat on what this session is and who this session is about. So I'm going to run down most of the basics of the if you have been involved in the blockchain or if you're working on projects, you probably already know a lot of them. But there might be some concepts that are new because I'm going to touch a little bit of, kind of start from a bit of economics side of things and then go to Bitcoin and basically, get towards introducing what blockchain is, what consensus is, and all of that. So just a quick about myself. My name is Saif Akhtar. I have obviously a bachelor's degree. I did a master's. The second master's was sort of like something that I got interested in the and somebody was trying to speak. So the second master's was when I got interested in blockchain back in 2015, 2016, and found this university that was doing this course, and I thought it might be useful for me to actually make myself more like an organized learning. I've been a coder for more than 10 years. I've architected large-scale solutions and call myself a product builder. Right now, I'm a head of product at Panther Protocol. So that's my Twitter, I believe. If you want to follow me on Twitter, you could do so. What are we learning today? So since I will be talking about money and I would be describing sort of like different forms of money and how we have arrived here, at least I feel like the summary of the discussion is going to be the fact that there is no perfect money. And I'm not suggesting that Bitcoin is a perfect money, but I guess this is up to all of us and all of you to make this call and at least have some data in mind to compare between what traditional money is and what it does. When I say traditional, I mean fiat money and what it does, and then how it compares with Bitcoin as money. We will be talking about the technology in itself, that Bitcoin is a breakthrough technology, and there's a lot of potential that is yet to be realized, not just from a Bitcoin perspective, but everything else that is following the decentralized technology and other applications that are being built. Decentralization can change the interaction, relationships, which people in control do not like. Things are changing, and a lot of people feel that in the years to come, the way technology is going to drive the way humans interact with each other, humans interact with businesses, and businesses interact with business. Cryptography, which we will learn more later in the session. You will also learn how it can replace some of the traditional security systems. And I feel like new security mechanism will come in place in the world that we are going to live. Or maybe we won't be there to see it, but it's going to come. Last fact, which is a very important fact we are working on right now, obviously, is how the regulatory landscape will shift from being bounded to being more open. So you will get some glance on that. Obviously, this is a very introductory session. This is the first session. So I'm trying to keep in mind a lot of our folks here who are getting exposed to Web3. Um, so I'll be doing a mix of things and trying to introduce you to different facets of this. Obviously, there's a lot of learning, and there will be a lot of learning materials that will be shared. So let's start with a favorite topic: what money is and what it does. At the core of what the definition of money is that it should have three major properties. One is unit of account, store of value, and medium of exchange, right? And all these three properties constitute or majorly defines what a perfect money could be. Like, this is the purpose of money. Apart from these three definitions of what a money is, there are different criterias of money, right? I mean, it should be easily standardized. It must be widely accepted. It must be divisible. Must be easy to carry, for example. It must not deteriorate quickly, as a medium of exchange. So in that respect, a lot of people say, the volatility in crypto market, I'm not going to go there, but the volatility kind of defies this last purpose, which is like must not deteriorate quickly, because that's not the purpose of money is. There are different also theories of money, and we can touch a little bit on how different economists and different philosophers have defined money. There's something called private property theory of money, which in which community takes care of all its members. It's like the advent of private property, which led to money. And basically, because of this existential uncertainty, which is like, I need to borrow for the future. And that's one theory of money. There is this credit theory of money, which views market as the clearinghouse for settlement. And it feels like the economy runs because of the debits and the credits, and all money is debt. And as economy grows, there's more debt created in the economy. So that is the credit theory of money. There's also something called the state theory of money, which is the state being the government of a country, where the state imposes liability in the form of generalized, like social unit of account, which is what they call money, and it's majorly used for measuring obligations of taxes. So money has value in this respect because it cancels tax obligations, right? And then, so these theories were largely sort of like the conceptual ones, and then there are a lot of like I was saying, economists and different school of thoughts. Austrian being one, Keynesian being the another. Marx obviously has more like social side of how he defines value. And in his respect, value is just the embodiment of socially necessary labor. So commodities exchange is in proportion of the labor needed, and that's how Marx viewed money is. So in his respect, money is mostly a commodity. So it's a commodity theory of money. In the Austrian theory, money is also a commodity, but it's used for medium of exchange like any other commodity, but it derives its value from supply and demand. And unlike any other commodity, increase in supply of money does not benefit society. So in this case, the MMT, or the modern monetary theory, is also called the neo cartelism. We can think of it like that. This is where government is the monopoly supplier of its currency and can issue currency of any denomination, in physical or non-physical form, which is the fiat money that we all use today. Um, it's also sort of like important, and I drew this because I wanted to kind of give an idea of how money has evolved and what is the history of money, starting from barter. We all know the barter economy. Um, Economists believe that there was never a large scale barter system that existed. It can only exist in very small scale with a little smaller group of people, obviously, because it does not solve the problem of the double coincidence of wants, right? Two people don't have the same value to exchange. And so the primitive money, which was like cowrie shells or even like grains that were used for money, kind of tried to start solving that problem, which kind of became like the medium of exchange. Um, and so after that, there was like trade began, and people felt um, it's not viable to carry large, grains where they want to go and trade. Obviously, metal came into place, um, and then there was like notes which were redeemable in metal. But again, these were harder to carry, and these all, as you can see, led to the development of modern banking. Like checks and e-money and debit cards and things of that nature. Um, So, when we talked about the MMT and the modern monetary policy, which is backed by the government, things go wrong. I'm not going to go into detail, but deflation is a general decline in prices of goods and services. It's typically associated with contraction in the supply of money and credit in the economy, and the purchasing power of currency rises over time in deflation. And so deflation can happen. This picture is from the great bank run, where people thought, people don't, government or banking system, sort of like the central bank and then the other banks, um, they don't have money. So people sort of like run after money. And there's like big queue in the American Union Bank. Now, inflation is good in general sense, the economists feel 4 to 6%. But hyperinflation is bad. And we have seen a lot of countries. I have myself witnessed, I've been to a few countries where you have to pay, like, I don't know, I've paid 100,000 of that currency to actually get a meal. So this was bizarre. If you are carrying physical notes, you literally have to carry a bag of notes to buy a cup of coffee. And I'm not going into detail into why this happens, because obviously you can read, and you can blame the policy or how the fiat money is being managed, how interest rates are defined, and things of that nature. Because obviously finance is not science, so it's all man defined process. Whatever works for the society. But you can learn about why these things happen. And because these things happen, there is this collapse in institutional trust in places where this happens. So if you see this diagram, government sort of like comes in the fourth quadrant, which is basically the most unethical and the less competent quadrant. And there are other businesses that comes in a different category. Um, so the whole idea of going through this concept of what money is and what it does, and the monetary policies of different governments, and things like that is going to lead to what we are, going to learn in the rest of the slides. Um, and further, the point that it's a blank slide is because I could mention n number of things that have happened uh, in the years that we have seen, but especially you can not go too far away. 2008 financial crisis, and the banking crisis was one of them that happened. And again, you can read why that happened. And there are different views of economists and banking professionals on trying to explain why certain things can happen. And again, this happened because there is a man made process, and not everybody, I should say it's not a perfect process. Um, and so with that, let's talk a little bit about, while the financial world works in the way that we just saw or we talked, um, there was rise of information age, and internet was being widely used and is widely used, and we needed businesses and things to work on internet. Um, and because of the widespread use of internet, there was enormous amount of data that was being shared on internet. And at least a few years back, or maybe a couple of decades back, there was no good system of privacy on internet. And so people didn't know that data and information that you share on internet could be used for surveillance. Capitalism could be used for controlling you, and for a lot of different reasons. I mean, Facebook and Google and a lot of different companies that relies on, and their whole business model is basically based on the data that you share, has the potential of using that data for not so good purposes, at least for purposes that is not good for humanity. It's not good for democracy, and it's not good for privacy. Um, so, with these things in mind, there were systems that were being built by cryptographers, by scientists, by computer scientists, obviously. And so David Chaum came up with a system called electronic cash system. And the idea of electronic cash system was, how can you transact a digital money on internet? There was like this time stamping information that came, that prevented a document on internet to be actually uh, backdated or forward dated. So actually like fraudulent document, um, which exists in the real world. But the whole point was, if you share a PDF on internet and everybody shares them, how do you make sure that this PDF was created by this person on this date? Or for example, university certificates. If you are sharing on internet, how can you prove that this document, electronic document, cannot be tampered? And that led to the introduction of Merkle trees back then. Um, Hashcash, which was the concept behind also proof of work, which is one of the Bitcoin core mechanism used in the consensus protocol, was developed by Adam Back in 1997. And what it does is it introduced mathematical hash function, where if you want to send an email, you have to solve a mathematical problem to send an email. So it was basically done at that point of time to as an anti-spam measurement, or like really a denial of service attack that can happen if somebody is sending thousands and hundred thousands or millions of email to people, clogging the system. You couldn't do that if you're using this system, right? Because if you want to send an email to like 5% or 10%, that's okay. You can solve the problem if it takes like 30 seconds. But if you want to send 100,000 emails to 100,000 people, and if solving a problem takes 30 seconds or even 10 seconds, it's like hundreds of hours, and it's really impossible. So take these concepts as some of the basic building blocks of the concepts that were put together for Bitcoin, right? And so we will talk a little bit about Bitcoin here because Bitcoin formed the basis of everything that we are doing in the blockchain space and the crypto space. It led to the creation of programmable smart contracts. So obviously Ethereum and a lot of other players in the ecosystem, which were all inspired by Bitcoin. And Bitcoin was inspired by the things that I just talked in the last slide. All right, so let's talk a little bit about why Bitcoin, and we will also see in the next slides. I'm going to talk about decentralized ledgers. What exactly is a blockchain? I will touch on the consensus mechanisms, decentralization process, which is very important for a decentralized system to exist on its own. And we'll touch on the smart contract side of things, a little bit on DeFi and NFTs and why this is important, sort of like the application of crypto in the real world that we are using. All right, so let's jump. Okay, we right now, at least, well, when we talk about centralized systems, we are surrounded by centralized ledgers. There are everything that we do in the world, the businesses that we interact with are centralized, whether it's bank, whether it's a medical system, land registries, securities, hotel reservations. They are managed by central body. They are managed by the people who own those businesses. They have control of the system. They have control of the data that they store. And what this can lead to, or what this has led to, are the categories of risks, which are like exclusion. So if they don't like you, they can exclude you. If they don't like your color, if they don't like your religion, if they don't like the country that you're from, countries that apply sanctions and things of that nature, they can exclude you to use their systems. Is that a good thing? We have often seen corruption and dishonesty at every level of businesses. There's so many businesses in the history that have gone down because of high level of corruption. And the sole reason corruption can happen is because these businesses have control on everything that they do. And so it is really up to them how they want to act. Loss of record and other factors are important. This is more like data control and data management, but obviously this has happened. We have seen loss of data, and we have seen certain things that can happen because of systems and data being controlled centrally. When Bitcoin came, Bitcoin provided a solution specifically for all of these problems. It's an open, decentralized, cryptographically secure system. The ledger, which is like the database, is public. It's distributed. Everybody can inspect it. Everybody can keep a record of it. Every participants have the same permissions and abilities. You don't need a special permission to access the system. You don't need to be trusted. You don't need to prove anything. Um, and well, the last fact is participants agree that the current ledger state is the one that is the longest chain. But we'll see later what it means by the longest chain or not. But what it is emphasizing here is that there is a way where participants manage and make sure that the state, or let's say in simple term, the whole system is correct. Um, think of a banking system where there is no central body. There is no body that manages a banking system. And what Bitcoin has really proved is you can have a accounting system without security, without like firewalls, without permission systems, without a database manager, without, I don't know, risks people, without thousands of people that manage a bank, in big banks. You don't need those 1,000 people to manage a bank, but you can still create a banking system that is true, that is secure, that people can trust and rely on, and it's open and transparent, and everybody can basically see that there is no fraudulent activity that is happening. So in that respect, it was considered a great innovation, and the systems are being used for multiple other aspects of businesses uh, that can come out of this technology or these concepts. So let's go a little bit into technical aspects of what a blockchain is, why it is needed, how does it work. Again, a lot of time. Well, I would say that I've heard people using blockchain in very different concepts, and sometimes people think Bitcoin is blockchain, or blockchain is the only solution of a decentralized ledger system. But there are some sort of like myths around it, and just to clarify all the point, blockchain is not the only decentralized way to apply. You don't always need to create blocks. For that matter, you can have like a linked list of transactions that can link to each other and still apply the concept of consensus and decentralized ledger. But blockchain specifically um, is a system where transactions are maintained in what is called a block. Um, and every block is produced, and every block is linked to another block in the system. And the importance of creation of a blockchain is, well, at least in the Bitcoin system, is you spend a lot of energy and resources to create a block, and that's the security model of the Bitcoin blockchain. So if you look at the diagram that is there, that's literally, the security of the most latest block is basically dependent on all the efforts that are being made to create thousands of blocks behind it. So it is largely secure. You can't really say that a transaction is invalid, because every transactions after that block becomes invalid. And we'll see a little bit of how that security model play in. The structure of a blockchain or a block is that in the Bitcoin blocks, there is a header and there is the transaction. The data structure holds sequence of blocks. They are reversed linked list, where each block holds the pointer to the hash of the previous block. This is the important factor where I said all blocks are linked. They're linked because every block has a pointer that only points to its previous block. And it's created by creating a hash. And there is a Merkle tree of all the transactions that are there in the block. So what I'm going to do really is walk you through, do a demo of how it works, because that might be very useful of understanding really how this works. So again, this is the two different parts of a block. There's a header and there's a body. But let's do this. Let me try to see if I can click this and share. So let me. Let me quickly do this. So can you guys see my new screen or no?
No, we still see the quick demo slide.
Okay, so let me try to share the other one. Oops. All right, cool. So a lot of people who have been in this is like the best online screen to learn about what blocks are and what hash is. So real quick, hash is just a number this long for anything that you can imagine. So if I write, hello, this is the zkMonk bootcamp going on. I want to prove this thing. If you give this hash to people, this hash only and can only represent this text with 2 dots at the end. If I remove 1 dot, the hash completely changes. And so you can write everything that you want. You can pretty much put the whole book in here. You can pretty much put the whole library of books in here, and it will still give you one large number that uniquely identifies the set of data that you are trying to represent. And so this is very important in the next sort of like when we look how blockchain works. So if you see, this is basically what is used as the pointer, something that links each block. And so let's see what blocks are. As we were seeing, there is a header and there is data. And if you see, this block is sort of like a mined block. So you see 4 zeros. This is, at least in the Bitcoin world, this is the mining works, because at the 72608 nonce, you achieve 4 zeros. So let's put some data here. Hello, how are you doing? So let's say this is the data, right? This has, right now, this data converts to this hash, but this block is not mined because, so this is what miners do in the Bitcoin blockchain. When there are financial transactions that are happening, there is a complex problem that you have to solve. And Bitcoin has, every 4 years, I believe, when halving happened, the complexity of that problem changes. So I think in the beginning, it was like 4 zeros. The hash should be 4 zeros in the beginning. And so miners literally have to brute force the nonce in the system to come up with a hash that has 4 zeros, that starts with 4 zeros. So let's see what happens when I click mine. So it's mining. So at a nonce, which is 168,797 nonce, you come up with a hash that has 4 zeros. And so this proves that, sort of not prove, but this is what miners do. They publish this information and everybody validates it. And if it's good, new Bitcoins are created and a block is considered to be mined. In this case, it's green, so it's mined. So now let's look at what blockchains are and how they work. So if you still see my screen, there are like if I can, okay, there are like, well, there are like four. Well, I see 3 blocks, but there are more here. I don't know why. Okay, yeah. So there are like 5 blocks in here. So this is a blockchain with 5 blocks right now. And let's quickly run down with some examples. So if I say Alice has $20, right? We're literally creating a banking system here. Alice has $20. That's it. And I mine this block. So this is like the balance of Alice. This block is mined. And this hash, so if you see, this is the Genesis block. This is the first block. So there's no previous block. This hash 007C5 always becomes the previous hash of the next block. And so this block is not mined yet. So now let's say what happens is Alice is trying to do a transaction. So Alice sends $5 to Bob. So as a result of this, Alice has $15 and Bob has $5, right? And so this is the state of the blockchain right now, but it's not mined yet. So basically think of it like Alice and Bob sending a transaction to the blockchain with this information, and there are miners who would mine this information. So let's try to mine it. So this got quickly mined because the nonce was 2002. There is another hash that is created for this block, and this block is now mined. So everybody in the network now knows that this is the state of the blockchain. Alice has 15 and Bob has 5. So now Alice's balance is 15. If she tries to spend more than 15, miners will reject her transaction because she's trying to spend more than she owns, right? Because every miner, everybody in the network knows what her balance is. Now let's try to do real quick here. So now let's say Bob sends $2 to, I don't know, Saif. And Alice sends, again, $4 to Sarah, for example. So the new balances are Alice has, how much Alice would have? Like 11. And Bob balance would be 5 minus 2 is 3. And Saif has 2. And Sarah has 4, right? If it's wrong, you know what I mean. But so now let's mine this block. This mine is blocked, and now we have this situation. So there are new balances here. Now, again, you can keep on doing this and create new block. That's how blockchain works. That's how new transactions are added on the block and previous transaction records are kept. Now let's look at a very important point here. So let's say Alice was a bad actor, or Bob was a bad actor, and Bob wanted to go back and change and say, Alice sent 5 to Bob. Now, Bob has $5, but he wants to go and change and say, Alice had sent all 20 to Bob. Now, the moment Bob sent this transaction to the blockchain, this chain becomes invalid. And if you see, it's not just this block, but all the block after becomes invalid. And the reason they become invalid is because the hash of this block changes. The moment you change any data, the hash changes. When this hash changes, this hash changes. When this hash changes, this will change. And then every hash in the block going forward will change, and it will become an invalid chain. Now think of this. If this is a long chain and people have spent a lot of mining power and created new Bitcoin, which is their reward, the network will not agree to this. Because the network will say, I have more incentive to not believe this because all of this was mined and we have already received the incentive. And so if I change this, then everything that was received from this point onward become invalid, right? So this is sort of like the security premise of how blockchain, like this is literally like the Bitcoin blockchain, but pretty much the similar concept apply for most of the other chains in the decentralized systems that we see. Again, this is andersbrownworth.com. You can try it, and see how it works, and um, apply these concepts to understand how blockchain works. Alrighty, so let's go back to the. Let me see if I can. Okay, it doesn't allow me to just quickly change it, but let me go back to our demo here. Okay, so we have sort of like 20 minutes, so I think I'm doing good on time. So that was blockchain, that was Bitcoin. As things started to go, there was generalization of blockchain. This is what I was talking when I said all DLTs does not use blockchain. I think Hedera, for example, uses sort of like a private blockchain, but it uses other DAGs, I believe, and there are some other blockchain that, other decentralized system that does not use blockchain as the ledger. The core concept still being same. But in this grand scheme of things, if you see, there's cryptocurrencies which are part of blockchain, and there's the fintech world that has intersections with cryptocurrencies. Blockchain uses decentralized technology. All right, with that, let's dive into some of the core concepts, which are very important from the perspective of understanding what blockchain is and how it works. Now, remember, now we are living in the world of decentralized system. There is no centralized body to manage, control, make sure that double spending does not happen, make sure the system is right. There is no such body. There is like a group of unknown random people who are running nodes in the system, who are running this software, that are responsible to maintain the correctness of the system. How do they do that? They have to arrive at a consensus and say that this chain or this state of the system is correct. Consensus in general is arriving at a common understanding of certain things, right? Like if you're a bunch of friends want to go to a movie, you have to arrive, everybody has to agree to go to the same movie. And if you don't arrive by just talking, maybe you come up with a process. Maybe you say, let's toss a coin. So that's a process. It's probably, in that case, it's a consensus mechanism to arrive to a common movie that you want to see. Or if you don't agree based on the consensus or based on the process that you define between your friends, what's going to happen is half of you are going to movie A and half of you are going to movie B. And that's exactly what is forking in the Bitcoin or in the blockchain world. I mean, I don't know how many of you were there, but Ethereum forked to, Ethereum Classic became sort of like, they call it the main Ethereum, and then we have this new Ethereum that we have right now. And so they forked, they became their own chain, and they have their own ways or systems to maintain the sanctity of the system. So that, in a nutshell, is what consensus is or does. Now, colloquially, it refers to, like, we call it proof of stake, proof of work, proof of authority. There are different type of mechanisms for consensus. However, proof of stake or proof of work is not the whole consensus mechanism. They are just, they're mainly to protect the Sybil attack part of the larger consensus process. And so if we have to define a consensus mechanism, it's a complete stack of like really like ideas, protocols, incentives that enable a distributed set of nodes to agree on a state of blockchain. So there is a lot of things going in there. It is not just proof of work is not just everything that happens in the consensus. But just to define, proof of work requires miners to solve complex mathematical problem known as hashes. This in order to validate transactions and add new block to the chain. In the proof of stake, you have validators that are chosen to add new blocks to the chain based on the amount of sort of like ETH in the Ethereum world, the amount of ETH they hold, which is known as their stake. The larger the stake, the greater the chance of being selected to add a block to the chain. And these validators are incentivized to act honestly because they risk losing their stake if they validate fraudulent transactions or try to attack the network. There's delegated proof of stake as well, where the token holders vote for delegates, and these delegates actually represent the token holders, and they represent the validation process that happens. BFT, Byzantine fault tolerance. Again, it's a computer mechanism where unknown parties can sort of like agree, come up to a consensus mechanism. But the process essentially is to make sure that there is enough true people in the network, which is like 66% or some in blockchain. So there are more good actors than bad actors. And that's what's kind of the whole purpose of that process is. But the name is comes from the Byzantine army, where there are army generals, and if you're attacking, all army generals need to follow the same guideline. And so it's like you pass information to different army generals, and if the thought process is everybody should recede and come back, but this message is not properly communicated, or there are bad generals, some of those generals attack and some of those generals are receding back, you lose the war. To win a war, everybody has to do the same thing. So it kind of, the concept comes from there, but it's implemented in computers to arrive at sort of like prevent the Sybil attacks. Chain selection is a part of the overall consensus mechanism, like I was saying. Proof of work and proof of stake is not just consensus. Bitcoin uses the longest chain approach, where the longest chain is the total cumulative proof of work difficulty that was solved. Ethereum uses the algorithm for defining the weight of the chain. It has mixed, come up with this approach of the Casper mechanism and the Ghost, and it combines both of them and came up with a new name called Gasper, which was implemented in the Bacon chain of Ethereum. And that's the link that you can use. That's a paper written by Vitalik and a few other folks, defining how the new consensus mechanism in Ethereum works. Just checking the time. I might go beyond a little bit. I hope that is okay. But there are a few important concepts, and then there are a few slides which are like easygoing. I guess we'll not take too much time there. Incentivization is one of the biggest and very important aspects of trying to ensure that there are more right actors than bad actors in a decentralized system that ensures that the decentralized system works well. Um, and to define that incentive structure, there is there's something called game theory, which is study of it's an area where you study the mathematical model of strategic interaction between decision makers. And again, game theory is not a new concept in Bitcoin. It has always been there. And if you think of game theory, I think we all use game theory in our lives when we interact with different humans or businesses. We all use some sort of game theory to make decisions. And um, we compare between different models and we try to see which ones are better. Burger King, McDonald's, they apply game theory to try to understand, um, you know, how big their burgers should be, or how many layers of meat they should put on a burger. Which sells better, what should be the price of a burger in which country, and things of that nature. So in the context of Bitcoin and blockchain, we got to develop an incentive mechanism that discourage the nodes from misbehaving, or attacking the system. And so these schemes, what it does is it rewards those actors that try to maintain the system. They run the system. They're running a piece of code, which is called the node operators, which are important to keep the system alive anyways. But the other fact is they're also running a system that is correct. And so these two aspects are obviously important in the decentralized world, because somebody has to run the system and somebody has to make sure that the system is right. And so they get incentivized to do that. In the Bitcoin world, they get incentivized with new Bitcoins that are created when blocks are mined. In the Ethereum world, same thing, ETH are created. So I guess I went a little bit here as well. So I think you get the idea of why this happens. And I think here what I'm trying to say is these structures exist in our life, in the different type of governance mechanism in the society structure that we live in. It could be small, it could be like a private systems, which are like, for example, exist in some societies. It could be with small set of individuals, or it could be for a general public. So Nakamoto consensus, which is the Bitcoin consensus, is really something that works well in a large setup. Protocol rules are the rules and laws that are there, which are sort of like same as in the societal world. When there are isolating behaviors, there's police and there's judges and courts to make decisions. In the blockchain, those are handled by the protocol rules that are ingrained there. No one can really change it. There's obviously difference between the police and the judge and the court, because there are scope for not those systems. They're not always very correct and very truthful, as we have seen, versus a blockchain system or decentralized systems where these rules and protocols are coded ahead of time, or a smart contract, and no one can change those systems, and peers interact with the system exactly with the rules that are defined ahead of time. There is penalty function, which is also designed for bad actors. For example, in the Ethereum world, if you're caught going against, you lose your stake, and that's why, which is like 32 ETH, I believe, at this point of time. think I covered this. The last point really is what I copied from the Bitcoin white paper. It's always good to go read the Bitcoin white paper. It says the incentive may help encourage nodes to stay honest. If a greedy attacker is able to assemble more CPU power than all the honest nodes, he would have to choose between using to defraud people by stealing back his payments or using it to generate new coins. This is what I was trying to show when we were trying to make a bad transaction in one of the past block, how every other block becomes invalid. Okay. Enough of Bitcoin. We're talking about the compliance part in the DeFi world. And as I was saying, what most of the company are trying now is how can they implement a decentralized protocol that can help support compliance as well. The core idea being keep the ethos of decentralization, keep the ethos of transparency, still use blockchain for all the other features that it provides, but sort of like use, for example, zero knowledge and things of that other cryptography to enable data privacy from the point of view of like KYC, right? As an example, you can get your KYC done from one body that provides a KYC attestation, but then you can use this attestation and create a zero knowledge proof that you can then interact with any blockchain systems that you want to. And so in that ways, when you are interacting with other DeFi or financial systems on the public ledger, you're not providing your KYC information to all of them. You are only providing them a proof that you are a KYC user. And that proof is nothing but a cryptographical string of bit of data. And all these systems have the ability to take that proof and verify it, run a verification software on their end, and say, yes, I verify this proof, and I allow this person to access the system because he's KYC'd, and I can verify the proof. So there are new ways that are coming in play to enable compliance in the decentralized world. Okay. In the past few years, where DeFi has evolved, this picture gives sort of like a one image where you can see how DeFi systemization is done and how companies are trying to, what are the different systems that are being built, what are the different businesses that are there, what kind of process they're using, and where they are settling their transactions. So if you start from the top left, there's different kind of assets. There's coins, there are fungible tokens, there are NFTs. There are DeFi systems like exchange swaps, which we have seen as the first. If you go to DeFi Llama, the swap in itself is $1 billion industry. The total DeFi is, I guess it's reaching $1 trillion. I haven't seen the latest one, but there are protocols that does lending, borrowing. There is flash loans. There are market making. There is stable coins that are being issued. There is USDC and USDT and some other stable coins that are coming in. There is derivatives. There is a privacy solution. There is portfolio. So I think this is an old composition. There are a lot of new DeFi systems every day that are coming in place, and we are seeing new and innovation in this space. There's market mechanisms that are being used. Arbitrage is one of the biggest one. I think arbitrage is not just for DeFi, but since the advent of money and history, when money comes in play and when different countries and jurisdictions have their own money, arbitrage is one of the biggest opportunity that existed from, I don't know, hundreds of years ago. Liquidation governance mechanisms, DAOs have come up where there's a structure where uh, there is a set of people, token holders mostly, that govern the protocol. So they kind of agree on what changes should be done on DeFi. So there's like a Uniswap DAO, and there are other DAOs that are there in place that manages the changes that can be done. And they do that by a decentralized voting process, and they vote based on the amount of token they hold. Well, it depends on the voting mechanism, but the simplest one is one token, one vote, and things like that. Market manipulation talks about the different types of manipulation that can happen. And this is not new to DeFi or decentralized finance. It's been there in the TradFi space. And if you guys know what happens in the TradFi space, front running, pump and dump, wash trading, and things of that nature are pretty much sort of like the aspect of the financial world that happens, and there are a lot of solutions that are being thought to prevent such activities. All of these DeFi systems are settled in the distributed database, aka blockchain. So the settlement layer is blockchain, and there is instant settlement for most of the blockchain. And again, if you see this, there's a consensus layers, and there's a network layer that exists at the bottom, which is the peer-to-peer transactions that happen. There are also some systems and some project that uses some part of their solution they implement in a centralized database, because not everything can be on chain. And so depending on the type of solution that you are building, what your user needs are, how scalable the solution should be, the speed of the transaction, you can design a system where some parts of the system can be done off chain in your servers, and you can pull information from the servers and feed into the blockchain using oracles, such as price oracles are prime examples of that. There are bridges that are sort of centralized, and we're not going to talk about that because that introduces a different set of discussion on the security margins of bridges and things of that nature. But this is really the non-atomic settlement that happens, which are referred to as off-chain computation. NFTs became very famous a couple of years ago or a few years ago. It's a very important aspect where you can tokenize literally everything that exists in the world. And what tokenization means is you are converting anything of value, whether it's physical or virtual, and making it into a digital token that can be represented and can stay on the blockchain. And the core idea is that when you represent a thing of value on the blockchain, then you can trade that value, and you can do different things with that value. You can not only prove ownership of something, but you can make sure that your digital representation that exists on the blockchain cannot be replicated in a non-fungible token. So, for example, if you see this little image of a meme cat by Chris Torres, well, unfortunately, or fortunately, I don't know, but everybody has different views on this. But NFTs, the first application of NFT became sort of like images and arts, and people thought and still viable in a lot of different cases, but that is not the only application of NFTs. So it's basically you can build an art, and you can create an NFT of that art, and you can store that NFT, and you can do what you want. There are platforms that trade arts, and there's OpenSea and some other platform that does NFT trading, and sorts of that. But the whole idea being you could represent any object of value on a blockchain. There are a lot of other use cases that are coming up. Um, Housing market and really um, ownerships, distributed ownerships of house, and managing that is one of them that we have seen. Um, there is metaverse, there is gaming, there's a lot of NFT in the gaming world that exists today, and gamers actually buy those NFTs and they sell it and they share it because it's of value, and it uniquely identifies who the owner is. So it's sort of like have the value that it needs, and it can be traded on the blockchain. Um, all right, I think we are almost done. So before I end this, few important points to learn here, sort of like a takeaway from a technical perspective, is a blockchain architecture refers to the technological components that comprise the architecture that implements a blockchain protocol. Peer-to-peer network, state machine, consensus, cryptography, game theory, incentivization, all of that is considered when you want to architect a blockchain solution. But not always. So for example, if you're building an application and using a layer one that exists, you don't really have to work on the consensus or the game theory, because you are basically just inheriting all of those capabilities that a layer one has. You're just building an application on top of that layer one. So you basically just concerned about how your application should work, how your smart contract should be safe enough, and how you can let users interact in your application. And that is basically the last point here, where I talk about decentralized application. Blockchain, again, is a distributed ledger that is structured into a linked list of blocks. Each block contains an ordered set of transactions. The solution uses cryptographic hashes to secure the link from a block to its predecessors. We have seen
Hey,
that.
sorry to interrupt again.
Yeah.
FYI, you're on mute. I don't think I see you talking. You're going through the slides. I don't think anybody can hear.
Is that true?
No, I hear well.
I hear well.
Hear him. Ben, you need to check.
Okay,
Maybe
so
it's on my side. I see other people. Their things
Right.
unmuting, talking, but I can't hear them.
Oh, you can hear them, but you can't hear me?
As I understand, he can't hear us.
All right. We are anyways at the end of this session, so let me just go ahead. I don't think we probably have time to fix it, but since it's working for all, I'll just go ahead. So again, this is concluding. So a smart contract refers to the code that you write that is executed over a network of distributed nodes without the need of trusted or central authority. Decentralized applications refers to web applications that runs a smart contract as the backend over a blockchain environment. And there's a front-end user interface that you can build. So front-end really is you can build in a React or any other application that you want. It just connects and sends transaction to a blockchain instead of sending an API call to your server. Think of it like that. All right, I think I am done with today's session. Again, thank you. Some of the references are here that I referred to prepare the slide. And that is my X/Twitter again. I appreciate everybody joining today's call, and apologies for the technical hurdle we have with Hurdle today, and we will try to fix that. So thank you. Bye-bye.